Well, my battery died when we were working on this problem last, so let's look at finishing it up. We had one point, and the x-intercept can be interpreted as another point. So given 2 points, we calculated the slope. Now, since I have a slope and a point, I'm going to use the point-slope form, which is y minus y1 equal m times x minus x1. Let's plug in our information, -3/2 for m, and we're going to pick a point for the x1, y1, whichever point you want, but I'm going to choose the -1, 0, which means I'll have y minus 0 equal -3/2 times x minus a -1. Y equal to -3/2 times x plus 1, just simplifying that double negative, gives me a final equation of y equal -3/2 x minus 3/2. And that would be the equation of the line. And that's the standard form, the form for slope-intercept form, and actually point-slope form ends up looking like that as well. So let's continue. Let's look at this equation. We want to find the slope and the y-intercept of this line and then graph it. Well, notice that this line is in our slope-intercept form. It's in the form of y equal mx plus b. Remember, f of x and y are interchangeable. So this equation looks like y equal -3/5 x plus 7. Well, there's the slope, -3/5. There's the y-intercept, 0, 7. From this information, we should be able to graph the line. Remember, the slope can be interpreted as the rise over the run. Slope of -3/5, if I put the negative with the 3, means the rise is -3. Rise is how far you go up or down, and the run is 5, and the run is how far you go across. So let's use the shortcut method for graphing this. We're going to start at the y-intercept, 0, 7, right there. Then from that point, we can do the rise and the run and find another point in our line. So from this point where I'm going to start at 0, 7, I'm going to rise down 3, 1, 2, 3. Then I'm going to run across 5, 1, 2, 3, 4, 5. And what that does is it gives me another point on my line. I can connect those 2 points and graph my line. So connecting those points, I've graphed the line y equal -3/5 x plus 7. We have to have 2 points. The first point is the y-intercept. The second point is doing the rise over the run. Rising down 3 because it was a -3, and running across 5 because it was a +5, running to the right. So let's graph some other equations. That's a quick and easy way of graphing an equation if you know the slope and the y-intercept. Let's graph these. We want to recognize these. This first one, it's in the format of x equal to a constant. And if it's x equal to a constant, it's a vertical line. Well, it's easy enough to draw a vertical line, but the question is, where are we going to draw it? Well, I don't have any choice. If it's x equals 6, that's where I'm going to draw my vertical line. So right there at the number 6, I'll draw a vertical line going through there. And my vertical line's not going to be great, but you get the idea. There we go. There's the graph of x equals 6. Do we recognize anything about y equal -2? Well, if it's y equal to a constant, it's a horizontal line. So I'll draw a horizontal line, but where? Well, I'll find where on the y-axis where we have a -2, which is here, and I'll draw my horizontal line. Okay, and we've graphed that equation. So x equal to a number vertical, y equal to a number horizontal. How do we interpret this? F of x equal 4. Remember, f of x and y are interchangeable, so that's just like saying y equal 4. It's a horizontal line. Where do I draw the horizontal line? At the number 4. So, basic equation up here we can graph with the slope and the intercept, doing the rise and the run and starting at the intercept. Vertical and horizontal lines, we'll just graph those as whichever one it appears in the equation. X equal to a number vertical, y equal to a number horizontal. And finally on this sheet, let's look at the x and y intercepts for an equation and then graphing it. So let's see. We want to find the x and y intercepts for each equation. So let's start off with this, and remember, how do you find x and y intercepts? Well, for the x-intercept, you let y be 0. For the y-intercept, you let x be 0. If you want to do a table of values, you let y be 0, you let x be 0, and complete those ordered pairs. So if I let the y part be 0, I get 3x plus 0 minus 5 equals 0. Well, it says 3x is equal to 5, so x is 5/3. So there is my x-intercept. Now let's find the y-intercept by plugging a 0 in place for x. 3 times 0 plus y minus 5 equals 0. So that part is 0, so I get y minus 5 equals 0, so I get y equal 5. So there's my x and y intercept. It says to rewrite it in slope-intercept form and state the slope in the y-intercept. So now, let's write this in slope-intercept form. Excuse me. And the way that is done is just we have to solve it for y. Let's solve it for y. So for 3x plus y minus 5 equals 0, let's get y by itself. That means I'd have to take the 3x over, becomes a negative 3x. Take the 5 over, becomes a positive 5, and there's my equation. Y equal negative 3x plus 5. Well, it wants us to state the slope in the y-intercept. So the slope is negative 3, and the y-intercept is 5. Now we want to graph it. Well, you can use the two ordered pairs, the x and y-intercept, or you can use a shortcut starting at the y-intercept of 5 and doing rise over run. This is negative 3 over 1. So the rise is negative 3 and the run is 1. So I can start it at 5 and go down 3 over 1, which would put me another point on that line, and I could connect those dots. This one and this one to graph that line. Or I could have used the 2 points. 0, 5 would be here, and 5/3 0 would be there. Let's do the same thing with this one. Let's go ahead and find the x and y-intercept. X-intercept, we let y be 0. Y-intercept, we let x be 0, and find those 2 points. So if y is equal to 0, I get 6x plus 15 equals 0. If I solve that, 6x equals negative 15. X is equal to negative 15 over 6, which reduces to negative 5/2. So there's my x-intercept. And my y-intercept, I let the x be 0. So if the x is 0, I end up with negative 3y plus 15 equals 0. Well, I'll take the 15 over, divide by negative 3, so I get y equal 5. There's my y-intercept. So I have the x-intercept and the y-intercept, and I could use those points to graph it, but now let's take this and let's rewrite the equation in slope-intercept form, which means we want to take that equation and solve it for y. So 6x minus 3y plus 15 equals 0. Let's work on solving that for y. I'm running out of room here, but we'll need to take the 6x over, and the 15 over. So I'll have negative 3y equal negative 6x minus 15. And I will need to divide both of them by negative 3. So I end up with y equal 2x plus 5. You can read that. Y equal 2x plus 5. There's my equation. There's my slope. There's my y-intercept. And we can find those points, connect the dots, and draw our line. The slope is 2 over 1, and my y-intercept is 5. So I can start here at 5 and do my rise over my run, which means I'd go up 2 and over 1, which would put me right there. That gives me 2 points on my line, and I can connect the dots. Or I could use the 2 points. 0, 5 is here, and negative 5 halves 0 is here. So however you choose to graph that.